So this lesson had so much in it that I broke it into 3 parts. And so this is the third part. When you finish this third part, then you can upload the assignment. And I will space this out over a few days. So looking at this, we are now going to solve equations with exponents. So here are the bases. And what we want to do is try to get those bases to be the same. So you want to think about 27 is the same thing as 3 cubed is equal to 27. And 9 is the same thing as 3 squared equals 9. So I'm going to take both of those bases and rewrite them. So 27, and I'll use a red pen. 27 is 3 cubed, and then you still have the x subtract 2. And 9 is the same thing as 3 squared, and then you still have the 2x plus 5. With those bases both being the same, because it's an equal sign, we know that if the bases, here's the bases, are equal, then we know that the exponents will be equal. So we're going to put the exponents equal to each other and then solve for x. So looking at this, 3 times x is 3x, and 3 times -2 is subtract 6, and 2 times 2x, 4x, and 2 times 5, 10. And now I have an equation that's not too hard to simplify. Subtract the 3x over here. So -6 is equal to x plus 10. You're going to subtract the 10 over here, and x is equal to -16. Done. So looking at B, we want to try to get the bases to be the same. So the base is a fourth and the base is 8. Let's start with 8 because it's easier. We know 8 is the same thing as 2 cubed. 2 times 2 times 2. And 1/4 is the same thing as 1/2 squared, which is 2. You can bring this up top to the -2 power. So now you can see that I have both of those have the exact same base of 2. Here's a base 2 and here's a base 2. So let's go ahead and rewrite the equation. The 1/4 is going to get replaced with 2 to the -2, and we're going to raise that to the x plus 2. 8 is going to be rewritten as 2 cubed, okay? And we're going to raise that to the x minus 4. So now we're going to take and distribute the exponents. So we have 2 raised to the -2x subtract 4 equals 2 raised to the 3x subtract 12. And if you notice, I accomplished my goal of getting those bases to both be the same. If the bases are equal to each other, then we know that the exponents will be equal to each other. So how do we figure out what x is? We can simply just take those exponents and put them equal to each other. So -2x subtract 4 is equal to 3x subtract 12. So we'll add the 2x over here, and we get 5x, and then let's add the 12 over to this other side. I'll use green so you can see what I'm doing. So plus 12 plus 12, and those are going to cancel. And over here, those canceled. So we have 12 subtract 4 is 8. So my final answer, if we divide by 5, is going to be x equals 8/5. Okay, so I took the 4 and I rewrote it as 2 squared. And 2 squared is being raised to the 2x subtract 7. And then do you see the square root here? Then I'm going to have to take the whole thing to the 1/2 power. All right. And then on the other side, I went ahead and distributed the 3. So it's 2 raised to the 3x subtract 3. So let's distribute the 2 here, and then let's cut everything in half. Or you could take the 1/2 and multiply it to the 2, which gives you just 1. And then that's going to give you 2x subtract 7. So 2 different ways to do it. I kind of like that way because it's quicker. So this 1/2, you can multiply it to the 2 before you distribute, and it cancels. And so now I just have 2 raised to the 2x subtract 7. So 2 raised to the 2x subtract 7 equals 2 raised to the 3x subtract 3. Stop the video and try it on your own now. Because the bases are the same, you can put the exponents equal to each other. So if the bases are equal, then we know that the exponents are also equal to each other. So take 2x subtract 7, put it equal to 3x subtract 3, and solve for x. And your final answer on that one is x equals -4. Perfect. All right, let's go ahead and look at D. I'm going to stop this so I can get more room. So to save time on this problem, I thought I would just go ahead and explain it to you. So my goal is to get all these bases to be the same. So I wrote 16, 8, and 4. And you can see that I was able to write 16 as 2 to the 4th power, 8 as 2 to the 3rd power, and 4 as 2 squared. So they all have a base of 2. So here's the original problem. And all I did is everywhere I saw 16, I changed it to base 2, 2 to the 4th. 8, I changed it to base 2, 2 to the 3rd. And 4, I changed it to base 2, 2 squared. So now you can see from here, I'm just going to simplify. So distribute the 4, distribute the 3, distribute the 2. And you can push pause and then come back and look at it. From there, you've got this equation. And so you're going to notice you're dividing and you have the same base of 2, which means you can subtract the exponents. So I'm a little worried about errors on this. So let me just 4x subtract 3x. I'll write it over here. So here's my exponents. 4x subtract 3x, which equals 1x. And so that's that x right there. And then you have 8, and you're bringing this -3 up top. So it's 8 subtract -3. And that's going to be 11. So 2 raised to the x plus 11 is equal to 2 raised to the 6x plus 2. From there, it's super easy. Your bases are the same. So set the exponents equal and then just solve for x. So x equals 9/5. Let's look at the next one. So this example, we're going to make the graphical connection to the algebraic problem. So the very first thing I'm going to do is solve this equation algebraically, and then I'm going to solve it graphically so we can see that we get the same answer. So what we've been doing all along is we've been trying to get the bases to be the same. And so I want to rewrite that 1/2 as a base 2. So this is 1/2. 1 over 2 to the 1st power. So you can take this 2 and bring it up here as long as you write it to the -1 power. So now I have 2 to the x plus 3 is equal to 2 to the -1, and then you still have the x plus 1. So now you can see that I succeeded in getting my bases the same. So now I can worry about the exponents would also be equal. So I can set those equal and figure out what x is. So now I have, let's come here, x plus 3 is equal to the opposite of x, subtract 1. And from here, we can take this x and add it over here. So we have 2x, add the x, plus 3 equals -1. Subtract the 3 to the right. So 2x equals negative, let's see, we're going to subtract that, -4. Divide by 2, and x equals -2. Okay, from there, we're going to switch to our graphing calculator, and we're going to graph this side of the equation under y1 and this side of the equation under y2. And then let's calculate the intersections to see if these are, to see what the solution is for x. So if you do not have a TI-84 graphing calculator, you can walk through this just by watching it, or you can also pull up Desmos on your computer and try graphing that way. So what we're doing is we're going to go to y equals, and we're going to type in 2 raised to the x plus 3, that's the left-hand side, and then green alpha F1 is going to give you a fraction bar, which I really love. So I am going to go ahead and do green alpha F1. I'm going to use a fraction bar, and I'm going to put 1 over 2. And then I'm going to arrow out of the fraction bar, and then I'm going to hit the raise 2 key. The raise 2 key is right here below the clear. And then after we hit the raise 2 key, we're going to type in x plus 1. So x plus 1. And I think a standard window will work just fine. So you can hit zoom 6 for that standard window. And I'm looking for the intersection, which should be at -2 because that's what I solved it as. So see those intersections and see how it looks like it's exactly at -2. But if we want to calculate it to make sure, you hit second trace, which is second calc, and then the intersection is 5, so hit 5, and you can arrow closer to the intersection if you want, but basically it's somewhere right there. So enter for the first curve, that's the blue curve, enter for the second curve, that's the red curve, and then enter again for your guess. And it tells me that my intersection is at when x equals -2. So the solution algebraically was -2, and the solution graphically was -2. And again, we're just solving for x, so I'm just looking at the x value. So we're going to graph the last one using the graphing calculator as well. So the first equation for this last problem is 2 raised to the x plus 3. So we'll do 2 raised to the x plus 3. Now, if you're on a TI-89, you have to put parentheses around the x plus 3. The 89s really do like a lot of parentheses. And then for the y2, we're going to put in 2 raised to, and oh, actually the base is 3. So you can go back to the 2, and you can actually just type right over it. 3 raised to the x plus 4. And on this one, you have to arrow out of the exponent before you put subtraction. And just a basic review is here's the subtraction and here's the negative. and you want to make sure you use subtraction. So you're going to put subtract, and then you're going to type in the 1. And then because I already did a zoom 6, which is a standard window, you can just simply hit trace, and it's just going to trace out those two sides of the equation. Okay, so now what we want to do is we want to calculate the intersection. So it's second calc, and intersection is number 5. You can arrow down and hit enter for number 5, or you can just type in the number 5. And then enter for the first curve, that's the blue one. Enter for the second curve, and then it gives you your guess, and then it will give you your intersection. So the answer to this one is negative 3.5178. We're always going to round 3 places in this class. So we're going to get negative 3.518 for our solution. The last 3 problems, you can try it on your own and just check the answers, or if you feel like you need help with the calculator, you can continue to watch, and I'll do the last 3 problems really quickly. So looking at number 1, I go to y equals, and I'm going to do 2 raised to the x, and you guys, again, x is right here to the right of the green alpha. So it's 2 raised to the x plus 1. And if you don't have a graphing calculator, no worries, because second semester, I'm going to try to have them checked out to you. So, and then 3 raised to the opposite of x. So we'll practice this again, plus 2. If you can afford a graphing calculator, or maybe it's something that you want to get for a holiday gift or a birthday gift, then I would really recommend this one, the TI-84 Plus CE. Is a really great calculator. Mr. Christensen, if you're going to AP Calc, will check out the TI-89 to you as well next year. So that's an option as a checkout. I do like the 84s more than the 89s because they're a little bit easier to use. Okay, so I have 3 raised to the negative x plus 2. And then I'm just going to hit trace. And then I'm ready to calculate. Second, calculate. Now, if you have a graph with a whole bunch of intersections, then you will want to hit trace, and then you'll want to trace this close to the intersection that you're trying to calculate. Otherwise, you can just hit enter for the first curve. Your calculator talks to you right here. Enter for the second curve, and then the calculator says, hey, is that your guess? Yes, it is. Enter. And then it will say, all right, well, the intersection is at x equals 0.839. So the answer for that one is 0.839. All right, let's go to the next one. So y equals, and the left side is 2 raised to the x subtract 3, x is to the right of green alpha. And make sure you use subtraction, not the negative sign, or you'll get it wrong. And then arrow out, put subtract, subtraction, subtract 2. The second side of the equation is negative 2. So this time, instead of using the subtraction, you're going to use the negative. My fingernails look awful. I need to get my nails done. All right, it's coronavirus season, so no nails done. All right, never mind. So you have negative 2, and I better clear out the last equation. So negative 2 raised to, and then you have x subtraction 2. So I really recommend, if you have a calculator, to put this in yourself, because it really is easy to type it in incorrectly. And then you have to arrow out and then do the plus 2. And then you're going to hit trace. You're going to look at your 2 intersections. And by the way, if you do not see your intersection in the window, you'll need to zoom out because it won't calculate it if you don't see it. But I do see it. So second, calculate, and then I've got intersection, enter, 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 and 3.415. All right, and then I'll let you go ahead and do the last one on your own and then just check your answer. Thanks, guys. Have a great week.